Hi, in this video we will enable depth testing in our pipeline. This will allow us to render 3D scenes where some objects might be or might not appear in front of others. So I start by adding a new function for the Vulkan initialization. This function is called createDepthResources. I will then go to the initializeVulkan method and I call that function in the end. And I will also find a suitable region to create this method. Here I create the method's body. The depth testing that we will enable requires us to create a texture. In this texture, different objects will write the depth values. If they're closer to the camera than the previous depth value, and if the pixels pass the test that they're closer to the camera. Then the final color will also be blended into the frame. Similar to how in a color image we can have red, green and blue, in a depth texture we can have channels. And depth textures are usually combined with another texture called a stencil. We're not exploring stencils currently, so the first thing we'll need to choose is a suitable format for a depth-only texture. I will create this constant VK format that will equal a 32-bit float depth format. And I've made a small typo here in the VK format type. Next, we will go to the header file. And unlike the frames where the image is created for the surface, we have to create an actual texture that we will attach to the pipeline. I call this texture handle depth texture. Now back at the create depth resources, I will make the depth texture to equal our create image from the texturing lessons. The depth texture should have the same extent as the frames, but we will have to make a small addition to this create image. We need to be able to pass in the VK format as a parameter. So I add it and then I also use it down here where we set the format for the image info. Now we also need to add this parameter inside the header file declaration, just about here. And back at the CPP file, we would have to fix the texturing code to include this format. So here where we create the image, we pass in the RGBA format for the textures. So for the depth, we can pass our new depth format now. And this will be this value here. The usage flags for this image is the depth stencil attachment bit. And we totally want this texture to be device local. We will not be reading or writing to the depth texture from the CPU. We can also create an image view for this texture by passing the image and the format. And for the image view, we also have to make a slight correction. Here in the aspect mask of the image view, we're currently setting this aspect color bit. So we need to pass in a parameter of VK image aspect flags and use this new parameter instead. For this to compile, we have to go to the header file as well and correct the method declaration. And of course, we have to correct all previous calls to this method, which is both for the create image views and also for the texture image view creation. And for our depth texture, we will set the aspect depth bit. Now, since the image starts in an undefined layout, we also have to transition its layout. So let's call this transition function that we wrote for the textures and transition our image from undefined to depth attachment optimal. Now, if you remember here in the transition layout, we specified in a barrier when should this texture layout be ready. And we need to add an else if check. If the layout is undefined and transitioning to depth. The source access mask is 0. The destination access mask is depth stencil attachment read bit, or the depth stencil attachment write bit. The graphics pipeline will have to both read and write to the texture at different stages, and the source stage is top of pipe. The texture needs to be ready at the early fragment tests bit. We also have to make a correction to the aspect mask, but let's not have it in as a parameter this time. We can deduce to change the aspect mask by testing if we're transitioning to depth optimal. But just to keep things local, I will actually move the color aspect in an else statement. Now that this is ready, let's also make this change here where we transition the layout to transition to depth and stencil attachment optimal. Now the depth texture is actually something that is attached to the render pass. So we need to go to the create render pass, and here where we create this color attachment, we can copy pretty much the whole attachment description and ref creation. We'll name it depth attachment and depth attachment ref. The format will be depth 32-bit float. Unlike the color, we will not care for storing the result of this texture attachment. And the final layout here will have to be our depth stencil attachment optimal. For the reference, we'll set this as the second attachment, and it will have the same layout as up here. Now, here in the main subpass, we can set the depth and stencil attachment to the ref object. And for the whole render pass creation info, we have to create an array of our two attachments, for the color and for the depth attachment. And we pass the attachments data and size here. Now we need to do something a bit weird. We have to add a subpass dependency. This is because of something I haven't talked about before. But our frames and our depth textures are cleared at the beginning of our render pass. The clearing process of the frame is actually an implicit subpass. And we didn't have to do it previously because we created a semaphore. This semaphore took care that our frame was ready and cleared before our graphics pipeline renders to it. If we didn't create this semaphore, we would also have the option to create this VK subpass dependency. We said that the source subpass is external, and the destination subpass is our main zero subpass. The stage mask is the color attachment output, which essentially means before rendering, and the access mask is 0. And the destination stage mask is the same, but with the access mask set to write. So we make our main subpass color attachment writing to be dependent on the external subpass, which is the attachment being cleared. I usually find the semaphore syntax a bit more clear. And we can pass this dependency to the render pass info below. Now, to add the depth texture to it, we just need to set the dependent stages as the early fragment tests, and the access mask is the write to the depth texture. Now, if we were rendering multiple frames together, we would need more than one depth texture. But since we've set up the whole program to render one frame at a time, and semaphores take care of this to happen synchronized, I can just go to the frame buffer creation here and I'll make these attachments into an array. The second value in the array will always be our single depth texture. Now I just have to pass the attachments data and size. Now, since the texture is needed for the frame buffer, let's move this code above the frame buffers, and we can go into the rendering aspect of it. When we begin the rendering commands, we need to clear our depth values. Here I will expand these clear values into an array. The first value will clear the color attachment. The second clear values will clear the depth stencil attachment. Depth values go from 0 to 1, where 1 is the farthest away that will be rendered. So by default, to clear the frame, we just need to set the clear value to as 1 or as the farthest possible. This way, if something is rendered closer, then that value will be taken. And we set the clear values data and count below. In the render pass begin info. Now we need to set up our graphics pipeline to enable the depth testing stage. To do this, I navigate to the pipeline creation method, and here where we enabled the color blend state, we can create a new struct called vk pipeline depth stencil create info. We set the S type, and after that we set the depth test enable vk true, the depth right enable as well. And the compare operation will be less. This means that it will take the pixels that are less than the current value in the depth texture. We can test that the depth values are within bounds, and the bounds are between 0 and 1. And finally, we will disable stencil testing. This info object can be passed in with the pipeline create info by setting the respective depth state field. Now, one last thing that I remembered. When I created this function for the depth resources, we used transition image layout, but we cannot transition the image layout before we have the command pool created. So we have to cut this code here and paste it at the end of the initialize vulkan. And before finally running this code, let's go into the destructor and destroy this texture. Now I build a project and I run it. You'll see that this now looks more correct in the 3D space. I close the window and notice this error though. This is caused because when we create our logical device, we have to request depth testing as a feature. Some graphic cards might not have this feature available at all. We can do this by setting the depth bounds to true and depth clamp to true. Building and running now should yield no errors. And this seems to be the case. Well, we now have working 3D rendering engine.